So moving on to lecture number 3. So what we are going to do, we're going to do additions and deletions in a linked list, basic simple functions. So for any data structure that you create, anything that you define, you have to define certain operations that you can perform with them. So when you have arrays in your program, what you might be doing with the arrays is adding items, deleting items, printing the array, sorting the array, printing in reverse order, or any other function that you want to perform, add all the numbers, find the average, and so on. You must have done a lot of programming during your C programming course with respect to array. Array is a data structure. It is a predefined data structure. It's already there. You just have to declare it and you can start using it, and then you can manipulate or do whatever you want to do with that data structure. So when we define a data structure, we also define the properties, how the data structure is going to behave or act, what operations you can perform on them, and that is what constitutes the definition of your data structure. So for linked list, it is a simple list. You can perform pretty much every operation on it, but when we go to different types of linked list, which includes queues and stacks, you'll see that the definition restricts the operations that we can perform on them. So for now, linked list, you can do additions, deletions. You can do additions in the beginning, in the end, or at any other intermediate location. Then similarly, you can delete start, end, or any other intermediate location. You might also want to print your linked list. You want to count the number of elements at any moment of time. You want to search something if something exists in the linked list, and there can be many other operations you want to perform. Find out if it's empty, print it in reverse order, or anything that you can do. But these are the basic operations. When you are creating a linked list, you'll be adding elements, you'll be deleting elements. You might want to print to see what is there. You might want to count to see the size of the linked list, and you might want to search. Okay, so first we'll do your additions and deletions in the beginning and the end for now, and then we'll see how we do the intermediate locations. So let's take this as our basic linked list, or you can say this is our current linked list in our program. This is what we have created till now, and we will use this as a base case to do our additions and deletions. Okay, so the first case is add at beginning. Okay, so when you want to add a node at the beginning, the first thing you have to do is you have to use your malloc function to declare memory equal to one node of the linked list. Then you add your data in it like we did before. So this is what you have to do before you proceed. So after you're done with this, you create temp node, declare memory here, then you put the data in. You can assign the next field to null. So this was our previous case. So for now we'll do this and this, and we have something like this created without the start pointer being in the picture. So this is what we have created. Okay, so I'm using the same node that we created. Now I want to add it in the beginning. So what do you mean by adding at the beginning? That means now instead of 5 being your first node, you want this 50 and this 50 node to be your first node. So what you have to do, you have to simply say that the start should point to 50 and this 50 should point to 5, and that is what you have to do to add a node. So what you have to do is you have to create, if you see these two green lines, we have to recreate these links. Instead of having this link now, we need to have this and this connection. This will ensure that 50 has been added at the beginning of the linked list. Now, which one would you do first, A or B? Okay, suppose we do A first. So what we are doing, we have to make start point to temp. The address of temp, for example, is 4000. So we will be overwriting start with 4000. So start will now point to 50, and this link is created. But in that process, you have lost the address of the node 5. Why? Because the address of node 5 was in start. Now start has been overwritten and you don't have the address which you can put here to link this to to link this to 5. So you cannot do A first in this case, you have to do B. So what do we do when we have to do B first? You first copy the address of the first node. The address of the first node is stored in start. So we take this address and we put it here. So temp to next is start. If you see here, we have put 1000 in the next field of temp. That means now temp is pointing to 5. Okay. Now this connection has been made because we are doing B first. And then after that, start. Now start also has 1000 and temp to next. This is 1000 and this is 1000. But now since we have already created the link between this node, this is the first node now. Now this becomes the second node. And now we will modify our start and make it equal to temp, which is 4000. So my resulting linked list will look like this. So I have a new pointer value in start, 4000 pointing to the first node, which is now 50, and then it points to 5 and so on. The list continues from there. So this is our add at the beginning. Now if we have to do addition at the end, what do we do? That means start all the way to the end. 15 was my last node. I'm again taking the first linked list that we have as the base case for addition. So when you have to add at the end, you have to add a node after 15. So again, if this is the node that I created, then I have to make this last node point to 50. And how will I do that? I have to modify this from null to the address of 50, which let's say it was 4000 again. So this field should be modified to 4000. And I've already made the next field of this newly created node as null. So my problem will be solved. But let's see this case one by one. In this case, I don't have to do anything with my start pointer. The start pointer does not change. But I need to go to the end of the linked list. How do we get there? So let's see, we'll see that in a while. How do we know the linked list has ended or we have reached the last node? So the only indication for us in a linked list which tells us that this is the last node of the linked list is that the next field is null. So we have to go all the way to the end so that we reach this last node. So to add anything, we need to first have the address 3000 in our hands. In our hands means that we need to have a variable that can hold 3000. Once we have that 3000, let's say it is in some variable temp1, then we can make the change, put temp, this is our newly created node, the node that has 50. We'll say put the address of this node which has 50 in temp1 to next, and temp1 is 3000. In the next field of 3000, put the address of temp, and that is how we'll do add in the end. So again, how do we get to the end of the linked list? We just have, as a programmer, you'll just have the start pointer with you. So let's see. We know we are at the end of a list when the next field of that node is null. So this is what we are going to use as our loop condition. For example, when you write a loop to print an array, what do? You say go from 0 to n minus 1. So your stopping condition is n minus 1. So what is our loop condition here? Our loop condition is when the next field of a particular node is null, that is when you know you are at the end of the linked list. Okay. So let's see first how we get there, then we'll see how we'll make the pointer changes. So this is a very important part of linked list because most of the operations that you will perform, you will need to loop through the linked list. In the sense, you will have to visit each node of the linked list to get from one end to the other end. You have sequential access. That is what we say for linked list. In case of arrays, you have direct access to any element in the node. Not in the node, any element in the array. And in case of linked list, you have sequential access. To access the second node, you need to first pass the first node. To access the fifth node, you have to go one by one. 1, 2, 3, 4, and then you will reach 5. So in most of the programs that you write or functions that you write for linked list, you will have to traverse the linked list or loop the linked list. So how do we do that? We know now that we have the start pointer, and to get to the end of the linked list, the condition is that the next field of the node will be null. So what we'll do is we'll copy our start pointer in a temporary variable. Okay, I'm using the same variable temp, the one that I used for new, but obviously we'll not do that in our program. This is just a small snippet, so we can do it here. So temp here for now is a temporary variable that I have defined. A temporary pointer to the type of linked list, singly linked list. So I copy the start variable that I have in temp, and then I start a loop. And what does this loop say? What is the condition in this loop? I say that if the next field of this node, so right now I'm at the start node, is not null. Okay, if the next field is not null, you go inside the loop. And what do you do inside the loop? You change temp from temp to next. So let me tell you what happens exactly. We come here, I copy start into my temp variable. Then in the while I check, is 1000 to next not equal to null? What is the next field of 1000? It is 2000. Yes, it's not equal to null. So you get inside the loop. You get inside the loop, and in the loop what you do? You say temp, which was 1000, is equal to temp to next. What is temp to next? Temp to next is 2000. So I'm overwriting temp with 2000 now. Okay, so now my temp is 2000. So now I'll go back in the while loop. Temp is 2000. What is 2000 to next? What is 2000 to next? As in, what is in the next field of 2000? It is 3000. So again, the loop condition is satisfied. It is not equal to null. So I'll go inside, and then I will overwrite 2000 with what is in the next field of 2000, which is 3000. So temp becomes 3000. Okay. Now temp is 3000, and I go back to my while condition. 3000 to next. What is in the next field of 3000? It is null. So 3000 to next is null. So loop condition is not satisfied. So you are exiting the loop now. And when you exit the loop, what was the value of temp? The value of temp was 3000 because the next field of 3000 was null. So now once you exit the loop, you have 3000. Okay. Now this loop, when you exit this loop, you are at the last node of the linked list. Okay, you are at the last node of the linked list, which is this node. But this is the node that we are going to delete. So let's keep that on hold right now and then see. There's another way of writing this loop which will help you traverse through the entire list, but it has a slight difference. So let's say if we write the loop like this, temp is equal to start, again the same thing, while temp is not equal to null. That means we are waiting for temp itself till temp is not equal to null, then only you jump to the next node. So for example, when we reach 3000, 3000 is not equal to null, and 3000 is equal to 3000 to next. Okay, 3000 is equal to 3000 to next. What is 3000 to next? It is null. So you'll go back and you will exit. So when you exit, your temp will be null. So that is not what we want right now. We are adding to the list at the end. So we want to be at the last node. So this previous loop is going to take us to the last node. And what do we do once we reach there? Let's say I'm defining a new variable new, which holds the address of the newly created linked list. Okay, we put data 10 for example in this, and we put next field as null. Start is equal to temp. Okay, start is equal to temp, and we use this loop. Once we exit this loop, this is the first loop that I showed you. So this loop has 3000. In the next field of 3000, I'm putting in this address of the newly created node. Okay. So by this, we are actually linking our new node to the last node and basically adding to the end of the linked list. So whenever you write this loop, don't ever use start here. Okay, because then you will overwrite start and then you will have no access to the beginning of the linked list and your program will crash. Okay, so this is your add in the linked list. So for your I'm going to end here because I need to make sure the videos are short enough. It's already 17 minutes.